फिर बाद में एक्सटेंड करेंगे सर, इफ वी वांट इंटरेक्शन।
Sir, with due permission of respected director, sir, may I start the program, sir?
Yeah, that's what I was saying. Please allow me to unmute.
Okay, thank you, sir.
All right. Yeah, please go ahead.
A very good morning to one and all. This virtual symposium on solar energy in post-harvest sector is organizing as a part of the Bharat Ka Amrut Mahotsav in commemoration of 75 Indian independence. So, a very good morning to one and all. It is customary to start with the ICAR song for any institute which is under ICAR. So, I'm sharing the song. Is it visible, sir? Everyone?
Yeah, visible.
आप करिए इसको, वो ऑडियो शेयर करके करिए।
Is it coming, sir?
No. Now it is start.
Is it coming?
जय जय कृषि परिषद भारत की सुखद प्रतीक हरित
वीडियो नहीं आ रहा।
कृषि धन पशुधन मानव जीवन दुग्ध मत्स्य फल यंत्र सुवर्धन।
गुरसंत को बोल दीजिए या वहां से कर ले।
मरुधरती से पूर्वोत्तर तक हर पथ पर है मित्र कृषक की शिक्षा।
Hello, sir. May I share it again? It's coming in my end. It's not showing in this. It's coming.
हाँ, फिर से करिए या गुरसंत को बोल दीजिए या वहां से होता है तो। You share it again?
Yes, sir. I'll say.
जय जय कृषि परिषद भारत की सुखद प्रतीक हरित भारत की कृषि धन पशुधन मानव जीवन दुग्ध मत्स्य फल यंत्र सुवर्धन वैज्ञानिक विधि नव तकनीके पारिस्थितिकी का संरक्षण शस्य श्यामला छवि भारत की जय जय कृषि परिषद भारत की। हिम प्रदेश से सागर तट तक मरुधरती से पूर्वोत्तर तक हर पथ पर है मित्र कृषक की शिक्षा शोध प्रसार सकल तक आशा स्वावलंबित भारत की जय जय कृषि परिषद भारत की जय जय कृषि परिषद भारत की।
Thank you. Now I request Dr. K. Narsia, Head, SNEC Division, ICAR CIPHET, also the coordinator of this program, to deliver welcome address.
Thank you, Vidya Lakshmi. It's my pleasure to welcome all of you, especially Dr. Nachket Kotwaliwale, Honorable Director, CIPHET, ICAR CIPHET, who has given critical inputs and always refined all the organization of all the activities related to organization of this symposium. And I welcome Dr. R.K. Singh, PC, PSEM, AICRP on PSEM, and also Dr. S.K. Tyagi, PC, AICRP on PHET. And I welcome my colleagues, other heads of divisions at ICAR CIPHET and Ludhiana, Dr. Brudula, Dr. D.N. Yadav, Dr. Ramesh Kumar, and also Dr. Sandeep Man, PME in charge, and all other. I see a lot of experts are also there. Dr. Dilip Jain, Dr. Navin Nayak, Dr. Manikandan, who are once part of our family. Still, they are part of our CIPHET family. So many others are also there. I see. I welcome them as well as all the other participants who are joining and who have joined. So it is a pleasure to see all of you. There is a saying that a journey is not complete when it doesn't go back to origin. So the energy, all the energy we are getting from sun. So the in evolution we have synchronized ourselves with the sun. So it started with sun, the evolution of life, and again we have. To meet our energy requirements, we have used different fuels or energy sources. Initially, we have used animals like horses, bullocks, and other things. Then we started using fossil fuels. Once the industrial revolution took place in Europe, so we started depending on fossil fuels, and technological developments were exponentially growing. So the consumption of these fossil fuels is reducing those resources, and again we have to go back to solar from where we have come. So our journey will be like a circle. So we to be sustainable in our development or in our goals, so we need to go back to solar. So with this aim, we have chosen that how solar energy can play a great role in post-harvest sector, especially, and in general, it is well known. But in our post-harvest sector, how it can play. So I welcome all of you for this bright morning, and it is virtually we can go anywhere from our seat. Let us go to the sun and then come back after the seminar. Come back to our seat. So this is the journey we will be taking you. So once again, I welcome you all for this symposium, and I thank all the participants who have joined for taking out their precious time to join us in this symposium. Thank you. Welcome one and all.
Thank you, sir, for your warm welcome address and brief about the importance of solar energy in post-harvest sector. Next, I request our Wadi Director, Dr. Nachiket Kotwaliwale, ICAR CIPHET, also the patron of this program, to give the opening remarks to the participants. Sir, please.
Okay, thank you, Dr. Vidya Lakshmi. First, I request the host to kindly mute everybody so that there is no disturbance. And that way, we can continue things. Thank you, host, for doing it. Okay, welcome to everybody. My colleagues, Dr. R.K. Singh, Dr. Tyagi, heads of the divisions, Dr. Narsaya, Dr. Yadav, Dr. Mridula, Dr. Ramesh Kumar. So we are all hosts. although in the banner of this particular workshop, I have been nominated as patron, but I would like myself to be called host for this rather than patron. All right. Forget about it. Now the issue is many institutes are conducting different types of webinars, and this has become a very effective media for transmission of knowledge. Although while doing so, it becomes very difficult because we don't have the eye contact with the participants. But still, this is a very effective media. We are able to save time. We are able to save resources. And now we are also, my colleagues, Dr. Yadav, he will very soon announce about the other kind of series of workshops and seminars that we will be conducting during the coming time. So this is one of them. Sometimes back, Dr. Narsaya again conducted one more similar kind of activity on disaster management related issues. So these are very specific issues, and rather than generalized talks by the different stalwarts, we are going to talk or hear from the people who are directly working in this field, who have done some good review of literature, who have also done some practical applications in the field. And in that series, I welcome Dr. Sita Chopra, who has been part of CIPHET sometimes back, and Dr. Murali also, who is from Fisheries Institute. And both of them have extensively used solar energy for processing applications. And my colleague, Dr. Lakshmi, who will also be talking about the miscellaneous applications of solar energy. Now, sun, as you know, that all scriptures of our mythological scriptures and everything, they have very aptly, they have told that sun is the center of energy. Sun is the energy provider. And as you see, the science also, everything ultimately gets related to sun. Even the fossil fuels, they have been converted because of the sun's energy that the earth receives. So ultimately, our whole or pinpointed source of energy is sun. And if you go back in many of the mythological stories and mythological scriptures, you will get to know that sun has been very effectively, or solar energy has been very effectively used for various applications. The only problem was that people didn't know how to concentrate it, or we forgot the technology of concentrating it, because more convenient fuel sources like fossil fuels or then hydrothermal converted into electrical. So these type of more convenient energy sources were available. So we didn't concentrate much on harnessing the solar energy. If we are able to harness solar energy, probably India and its nearby countries would probably be one of the most rich people, because we receive abundant sunlight. And we have definitely much more potential of using solar energy for various applications. On one side, we say that solar energy is a green alternative, although I will put forth some points contending this thought also. But anyway, nevertheless, we don't, because of solar energy, we don't emit any kind of gases, obnoxious gases, or any kind of hydrocarbons. We do not pollute the environment because of use of solar energy. And now you're going to witness during the presentations of these three speakers, all of us are going to witness that how these things can be effectively be done, and how do we increase the efficiency of these devices so that they become more dependable. This is the most difficult problem of solar energy use, that it has not become very dependable and it's not very concentrated. Concentration also becomes a problem. Nevertheless, there are solutions if you search in the internet also, and you will get to see some of the solutions today itself. I'm very sure that my three colleagues who are going to make these presentations, one of them from CIPHET, one of them ex-CIPHET scientist, and one from CIFT, they are definitely going to let you know that what are the advances in the area of solar energy. But on the other hand, while we are using solar energy, we need also to pay attention to one fact, that all the gadgets, especially the solar photovoltaic, what we are going to use, can we think of using some kind of recyclable or reusable material for developing the solar photovoltaic? Because if we are using some kind of polymer, 10, 15 years down the road, we might face a problem of disposing these type of things, and they may create pollution. Like it is happening in case of plastic mulching films. In many farms, the mulch films being plastic, they are becoming a menace. So similar thing may not happen in case of solar photovoltaic or solar electrical applications. We need to pay attention to it, and we need to bring this problem. Okay, as an agriculture engineer, we may not be able to address to this issue probably, but at least to the developers, we may pose this issue, and we may use these things so wisely that reusable or longer life of the devices can be ensured. This is, I'm very happy that this type of focused approach has been taken by our team from CIPHET, and Dr. Narsaya and Dr. Lakshmi, both of them. They deserve appreciation for choosing. And in the future also, I assure you that CIPHET will be proposing programs which are very focused and very specific to different types of technologies in the area of post-harvest engineering and technology. Thank you very much, and I am looking forward to a very successful presentations and very fruitful discussions in this workshop. Thank you once again, and I'm welcoming all of you and reminding all of you to follow the COVID-19 protocols of personal safety and hygiene. Thank you.
Thank you very much. Thank you very much, sir, for the welcome remarks and enlightening the participants regarding the various scope and opportunity of the solar energy and post-harvest sector. For this program, DDG Agricultural Engineering and ADG Agricultural Engineering also shared their message for this symposium. So I'd like to share their message on the screen. DDG Agri Engineering, he also explained the various scope and application of the solar engineering and also to popularizing them. And he also mentioned about the focus to the renewable energy for the sustainable growth and brief about the national solar mission of the government of India. He wished the symposium a very grand success. ATC Agri Engineering, he also conveyed the message the importance of the solar energy in different post-harvest sector operations like the steam generation, drying, cooling, chilling, storage, etc. He also conveyed the virtual symposium a great success for this in this program. So, in continuation of this program, I'd like to for the lecture, I request Dr. Sangita Chopra. I will answer. Okay, thank you. For this, coming to the lecture session, I request Dr. Sangita Chopra for her lecture. But before that, I would like to brief about her. Dr. Sangita Chopra is a principal scientist in Indian Agricultural Research Institute, New Delhi. She graduated in electrical engineering, power electronics from University of Roorkee and IIT Kharagpur, and has a doctorate in energy science and technology from PAU. She has more than 20 years research experience in ICAR in area of post-harvest technology like food processing, biomic heating, solar refrigerated evaporatively cooled structures, and has to her credit 1 granted patent and 25 international and national publications. She has engaged in research exploring the issues of MOFs for fresh food packaging in Michigan State University, USA. She has been awarded Fulbright Nehru Academic and Professional Excellence Fellowship for a program using finite element analysis to improve the design of the cool rooms. She has been granted 2 funds from USAID to develop inexpensive renewable energy-based cool storage structure for smallholder farms. Ma'am, please.
Okay. Well, good morning, everyone, and thank you so much for giving me this opportunity for speaking. And I'm very, very happy to be back. I was in CIPHET for a long time, I think around 15 years, and I know almost everyone here. We work together, and it's extremely nice. Gives a good feeling to be here now, virtually. So I'll share my presentation first, share the screen. So give me a minute, please. Can you see the screen? Okay,
Yeah.
great.
Yes.
Fine.
Yeah, thank you. So, well, so I've been working with solar energy practically for the last 5 years now with scientist colleagues from Michigan State University and also funded projects from USAID. And these are some of the results of the work that I have done. I've included some of the results and some general points that my scientist colleagues have already discussed. So as you can see here, I'm supposed to speak on application of solar energy in cold chain. The picture that you see below is solar refrigerated evaporatively cooled structure. And this is in Picholia, Rajasthan. It's been built 2 years back now, almost 2 years. You can see the back south side is completely full of solar panels. And this farm does not have any grid or no electricity. And it still runs automatically in the morning, stops in the evening, and is being used by farmers. So we like to call it the first link in the cold chain for perishables. The temperatures inside are like in a refrigerator. It's also batteryless. So you can see the field nearby, so the farmer can just take his produce from there and put it in this structure, which runs without electricity. It's like a cold store. And that's how I would like to start. Okay, next. Oh yeah, the overview. In this presentation, I would just briefly touch upon solar energy, solar photovoltaic panels, because that's very important when we are doing any work, the consideration, what are the characteristics that we have to see, the inverters, a little bit about the cold chain, and the Pusa farm sun fridge that we have developed. So many of you might be knowing this, but this is just to kind of remember again that out of the total installed capacity in India of 382 gigawatt in March 2021, renewable energy sources, as you can see, the green part here is 25%, whereas coal is like 55%. And the photovoltaic panels or photovoltaic energy out of this renewable energy contributes 8% of the installed capacity. And amongst the photovoltaic installed capacity, 90% is ground-mounted panels, around 7% is rooftop solar panels, and off-grid solar power is 3%, that is the solar water pumping. And that was the installed capacity, and this is the power generation. So the electricity generation in India is around 100 billion units per month, out of which renewable energy contributes to 10% of the total electricity generation. So you can see it's 11,241 million units. And amongst this renewable energy, you can see these bars. It's comprised of wind, solar, biomass, bagasse, and small hydro. And the orange bar is the solar, and the contribution is increasing per every month. So in the month of February 2020, solar photovoltaic systems produced 5085 million units, which is around 5% electricity per month. Solar energy in India, as has been said, is we are endowed with a large amount of solar energy potential. The solar installation is around 1,000 watts per meter square. So about 5,000 trillion kilowatt hour per year energy is incident over India, and most of the parts in India receive 4 to 7 units per meter square per day. That high amount of solar energy is here, and it is surprising that we have not used it. We should be using it more often for our cooling or processing plants or any other systems that we may want to run. So the primary part here is the solar photovoltaic panels. And they are just to revise a bit here. It's made from crystalline silicon, absorbs photons from the sunlight, releases electrons, which generates the DC current. Each photovoltaic cell has an operating voltage of 0.5 to 0.7 volts. And then they are connected in series, and many of those series strings are connected in parallel. So when they're connected in series, the voltage increases, and then all these strings in parallel increase the current, and that's how the photovoltaic panel is made. This is one of the most important characteristics of a solar photovoltaic panel, which is the current voltage characteristics. So you can see the open circuit voltage here, VOC, is important. That is when the solar panel is not connected to any load, and if you connect a multimeter, that's what it's going to give. And if it is completely connected without any load, then it's the short circuit current. So between these two, mostly we would like to operate the solar panel at the maximum power. As you see, PMP is the maximum power, and that is got from VMP, that's the maximum voltage at the maximum power, and the current at the maximum power. So these are the characteristics that are important. Now, the panel that I am using is a 415 watt panel. So I just took the data sheet from that panel just in order to explain what are the important considerations that we have to take and how do we understand the data sheet. So STC here is standard test conditions, which are the lab conditions. Oops, sorry. Give me a minute, man. Okay. So that is the standard lab conditions of 1,000 watts per meter square, 25 degrees Celsius, air mass of 1.5. Under these lab conditions, this particular panel has 415 watts, voltage of 39.3, open circuit voltage 47.8, and around 10 to 11 amperes current. Whereas the real world conditions are 800 watts per meter square, 20 degrees Celsius, wind speed 1 meter per second, and air mass of 1.5, where the power comes down to 309 watts, and the open circuit voltage comes down to 45, and the maximum power voltage and the maximum current is around 36.6 and 8 amperes. So 8 amperes is what we are looking at in real conditions. Apart from the module efficiency, this particular Canadian solar panel has an efficiency of 18.8%. So we would like to go for highly efficient solar panels. It can operate between very well between minus 40 to plus 85. Above plus 85, it will not give output. And the mechanical data, the data sheet also has mechanical data. So polycrystalline, it consists of 144 cells. So each cell is each small photovoltaic cell that we talked about earlier. And you have the size, the weight, connectors, etc. So one of the important characteristics in a solar panel is the temperature characteristics. So this is the nominal operating cell temperature. It's normally 40, for this panel, it's 42 plus minus 3 degrees. So it can work between 39 to 45. But above that, should the temperature go above that, there's a temperature coefficient, and all of these, the voltage, the current, and the power are going to reduce at these temperature coefficients. So the data sheet also has given the temperature coefficients, because this becomes important, because most of the time when we are working in India, our solar panels go above, I've seen temperatures go up to 60 Celsius, 65 Celsius in the summer season here. So this becomes an important criteria. Another important part that we have to right away look at as soon as we use it is what is the tilt angle that is important. So the thumb rule is, in the northern hemisphere, it should face true south, and in the southern hemisphere, it should face true north. And the tilt angle is normally equal to the geographical latitude. So if we want better performance in the winters, we try to increase 15 degrees, add 15 degrees to the latitude. So that becomes the angle. In the summers, they'll become more flat. So the latitude minus 15 degrees, so it's more flat, gives better performance. So for example, Delhi latitude is 28.7 degrees. And therefore in winters, we can tilt to 43.7 degrees. So this is with the horizontal. And in the summers, we can make it more flat to 13.7 degrees. So it's good. You can get a good performance out of solar panels if you're able to tilt. If nothing else, you're able to tilt twice a year. So once in the summers and once in the winters. And so you see here, this is the frame that we have for our, while it was being constructed, we took pictures. So this is made on the Mela ground, Pusa Farm Sunfish, the latest one we have. And you can see the angle here. It may look more than 28.7, but it is 28.7. And we do not have any method of tilting it in summers or winters. I wish we had, but that's kind of expensive. And we try to make it as low cost as possible. Now, in addition to the tilt angle, it is also important to, we can also increase the power output if we are laterally changing along the solar panel, along that along that plane, if we change towards the east or towards the west. So in the morning, the entire panel can face the east and then keep tracking it and turn the other side to the west. That is possible. And so I would like to show that these are called panel trackers, and they're on a mount that can follow the sun for getting the maximum sunlight. I wish we can do that easily. So this increases, mostly you can get increased harnessed energy of around 15% in winters and 35% in summer. Maybe a single axis or dual axis tracking, the automatic solar tracking controllers. Now in this table that you see here, you see from this is for Delhi. So from month of January to December, the first column, the second column that you see is the tilt angle. So in the winter months, it's around 40 Celsius, and then we can make it flat to around 10 in May, June, July, like literally flat, and then go back to 30, 40 Celsius. Now, what is interesting is during the time of the day. So starting from 6, 5, 6, 7, 8, this is the time starting from morning. So minus 60 is more towards the east. So the entire panel is facing the east sun, and then that goes flat, keeps turning, and is right overhead, like 0 degrees looking upwards. That's around 1 o'clock, and then going towards the west to 60 degrees. And so this is how, that's how I'm showing the minus 60, minus 30, 0, and 30 and 60 to the west. So that's another way, and that is being done at places. Okay, I want to go to the inverters next, because that is the next important criteria that we would like to consider or match. It's very important to match, we may say impedance matching, or match all the specifications of the entire system. So various kinds of inverters are available, and we've been searching for them for a long time. Some of them do not suit at least our purpose for villages, but some did. So the first one we can see here is an off-grid inverter, which requires a battery. So it's off-grid, that means it has no electricity connection, but it requires a battery. So there is no operation without a battery. So there are some specifications for a 5 kilowatt inverter. What is the battery voltage required? This is for one particular inverter. But what is important is that if I take out the battery connections, this inverter does not give an output, even if the solar panel is connected. So it's like as if the solar panels are charging the battery, and then we are getting the output. So battery is an essential component. It does not work without electrical supply. That's what should be there. There's no operation without battery, and it does not need a grid. Then we have grid tied without batteries, in which also around 5 kilowatt is what my system is. And we do require 100, say, an AC input voltage, but there is no output, and the solar panels, of course, but there's no output if there is no grid. So the moment electricity fails, there's no output from the inverter. So this is clearly not what we require, because in the villages, if there's no grid and if my system also stops, then there's no use of it. What happens here is I've written the word net metering. What happens is if your load draws less power and the solar panels are giving more energy, then that energy can go back to the grid. So many people prefer that, and they put this net metering where the meter goes in the opposite direction and your electricity bill may be reduced accordingly. Most of the inverters have communication Ethernet interfaces, and they can be configured via PCs, smartphones, and we can do data logging also. Gosh. Okay. Okay, it was simple. So the inverter that I am using is actually a hybrid inverter, but I am not using a grid and I'm not using a battery. And very few suppliers in the world are making this. Some of them claim to have this inverter, but when I bought them, they didn't work. So the inverter that I am using has a 5 kilowatt, it's around 5 kilowatt. And the maximum input that I can give is around 500 volts. The battery specifications are written, but it can operate without a battery. It can also operate without grid. Does not need battery, does not need a grid. I can use a grid if say I'm constructing this structure in a village where there is some grid and we can get that advantage. I can use that. But honestly, in some villages where I've put in Haryana, the grid quality is so bad that my inverter got destroyed. So because they have all kinds of wires that they are hanging onto the village electricity supply. So that destroyed my inverter also. Input voltage 220 volts, we do not need it. Presently, I'm not using battery, I'm not using grid, just solar panels, and we get an output of 220 volts. By far the best system that I have seen. And of course, if I'm connecting all three, we have there's a program, we can program it to solar first. So it is either solar first, battery. So SBU is solar first, then battery, then utility, that is grid, then solar first, utility or battery, or it can be utility, solar, and then battery. That's how it will take the power. If the solar is less, it will take from the grid. But it can operate without any, actually it can operate without any one of them. It can work just on grid, just on batteries, or just on solar. Cold chain for perishables. Well, we all know that a cold chain is required, and my team here is the effort is to establish the first link in this cold chain, a cold storage that works without electricity, does not need batteries. And of course, then there's transport and then processing and distribution. I would like to say that we have pumps running in our place where there's no electricity, but this structure is working, for example, in Ajmer, Rajasthan, in Picholia village. So we are running the motor for washing the panels from the solar panels. And this is a 5 kilowatt system. So if we do not use the structure, say the structure is not in use, then we can totally run some small processing machine from the same system. If we can run an air conditioner, we can run a machine too. And we are running motors, we are running pumps for washing the panels and using the water. So there's no electricity connection on that farm yet. Now they have electricity. So now you can see the same structure which I showed you, the frame. This is the Pusa Farm Sun Fridge, cold storage for farmers. This has been built on the Mela ground, and this has been built this year in the month of February for Kisan Mela. It was built in just 20 days and is working till today. And it is being used for storing produce from CPCT. So when the crop protection cultivation division, which is just behind the Mela ground, they have a lot of produce and they sell in the market. But before they sell in the market, they often keep their produce in the sun fridge now. The size is 10 by 10 by 10 mesh supported fabric walls. The fabric walls are wetted. So we have the advantage of evaporative cooling. And then we've combined solar refrigeration because we have styrofoam insulation. So there's no other battery for nighttime, but we've designed a water battery. It's a thermal storage, a plastic tank, but there's a system that we've used. We've split the evaporator coil of the refrigeration system. So it cools around 75% of the refrigerant is cooling the water and 25% is cooling the air. And that cold water, which is being cold during the day, reaches around zero. It almost less, it's just above freezing. So it's around 1 or 2 degrees. And that water keeps the entire structure cold at night. We are using a pump here of 5,000 liters per hour, a drip line for wetting the fabric. In this, I've used 12 solar panels, each of 415 watts or so, a split air conditioner, and the hybrid inverter that I've talked about without the grid and without the battery. Now you can see on either side, on the left side, you can see the inside of this structure and the pipes above. These are 4-inch pipes, and this is the water battery for nighttime cooling. And on the right side, you can see how the evaporator coil has been split. So this is where um, the refrigerant first goes into this, cools all this water, and then goes into the indoor unit. And we've made modifications in the indoor unit. We've pulled out uh, the circuit board inside, and we've modified so that we can get 2 to 3 degrees during daytime, and it goes up to 8 to 10 degrees in the night, because at night there is no active cooling, it's just passive because there's no solar energy. So this is off-grid and batteryless split evaporator coil, water battery for nighttime cooling, automatically starts and automatically stops. As soon as there is solar energy, it starts by itself. Now, this sun adaptive controller is something that we have devised. This is an important part of this structure, because if there are clouds or if there is less sunlight, then our system is going to draw less power. So that's what we have done here. We have modified so that the compressor and the air conditioner does not demand power if there is less sunlight. So we are sensing the sunlight, and then we've programmed it, sensing the sunlight and asking the compressor to demand less power. So that's how it continues to run, does not go into error. And we've added IoT because of coronavirus times. So I'm able to program it right from here because we've put internet and Wi-Fi into that system. And of course, it has high interior RH, which is a requirement. So this is the practical data that we have got from this structure. You can see the dates on the x-axis are from 26th of March to 1st of April of this year. And on the y-axis is the temperatures. And you can see the ambient temperature. Well, it was just March, end of March. So it was around 35 degrees Celsius. We are logging this, the results, the data of temperatures. And this is all 24 hours temperature every 15 minutes. Till today, we are recording every day. And so the yellow line here now shows you the solar panel temperature. So you can see when the ambient is like 30 on a particular day, the solar panel temperature, this is the actual real data, it goes more than 50. So I know from my experience, I've seen it, this temperature of the solar panels shoots up to 60, 65. It's uncomfortable, but that's how it goes. So while these are the temperatures on the outside, you can see the water battery that I've talked about, the thermal storage. So you can see the temperatures. So you see that this is the day and this is the night. So during the day, this part, there is the water temperature goes down, and at night time, the water temperature starts rising. So it goes down to around 0, 1, 2 degrees, and it can keep the system cool at night. So it goes up to 10. The black line here shows the inside air, which also remains below 10 Celsius when the outside is 30. And I'm saying that is nighttime temperatures. So the daytimes go pretty low, 2 or 3 degrees is what I see every day. And this is the produce. So you see when we harvested the produce and put it inside, it was almost ambient temperature, but it cooled pretty fast in a few hours to 10 and then continued to remain there. So we put lots of produce here. We put capsicum and all the winter vegetables in the late February month. Cauliflower, spinach stayed around 10 days or more. What I can see is we are publishing the data. So it's almost like 4 times that of ambient is the shelf life. And also it's just like a refrigerator that you have at home. Oh, and better because the RH is pretty high relative humidity. And this is the other produce. Of course, we kept another produce. We keep putting produces. All these temperatures are measured by thermocouples. And this is when we put the produce again. And we've been doing this a lot lately. And some more important considerations. So you can see what happened in the last few days when there was this cyclone. It happened in Rajasthan also. So the top picture I can show you, there's a processing plant in front of this Picholia structure that we have. That's the first picture that I showed you. There's a small processing plant, and it's around 100 feet or so long, and it has a roof over there. It had a roof until the cyclone came, and the roof just fell off that structure, and it just blew with the wind and fell in front of mine. So our structure is working standstill, still working till today. We've removed this part, but that's what that's what happens if we don't make a good structure. And our solar panels are still intact. Our overhead tank did break because of this. You can see the impact of this long iron piece. And my system, which is here actually, is safe and working. Everything is working except for the overhead tank, which broke. But I think it's important to consider here that it is very, very important to decide that whether our panels can withstand that wind speed. We don't want them blowing away if there is high wind. So the structural strength, the wind speed, the weather, the latitude are very important. And of course, one more important criteria is earthing. If we do not have earthing, there are many, many chances of people getting hurt or instruments going bad and things like that happening. And of course, the accessibility to install solar panels is important because we need to, it is so dusty and there's so much of particulate matter in the air that we need to clean it. So the farmer should know how to get up and wash all the solar panels. So that's what we've been doing here. Well, thank you so much. That's all I had to share. Thank you. I'll stop sharing.
Thank you, Dr. Sangita Chopra, for a nice presentation.
Thank you.
Yeah, next lecture. We will take the questions or queries after all the lectures are over.
Okay.
So others, they may put in chat box or they can raise hand when interaction is going on.
Yeah,
so,
thank you.
Yeah, you can go for next lecture.
Thank you very much. Before this, I would like to thank ma'am for explaining about the photovoltaic and its installation with respect to direction, latitude, etc. Also explaining about the different components, importance of the inverter and battery also, and the technology which he had developed regarding the Pusa farm service. Next, I request Dr. S. Murali, scientist, ICAR, Central Institute of Fishery Technology, for his lecture. Before he delivered his lecture, I would like to brief about him. Dr. Murali S. is presently working as a scientist at Engineering Division, ICAR, Central Institute of Fishery Technology, Kochi. He has completed his graduation from TNAU, Coimbatore, and master's and doctoral degree program from ICAR, IARI, New Delhi. He has secured ICAR CRF SRF fellowship during master and doctoral degree program. He has cleared NET exam conducted by ASRB, New Delhi, life member of different professional societies. His research interests include the solar energy conversion system, design and development of fish processing equipment and machinery, encapsulation of functional food ingredients. He has authored 15 research publications in peer-reviewed national and international journals, and also obtained 2 design registration, 1 copyright, filed 1 patent, and 2 design registration. He has also received Kerala State Energy Conservation Commendation Certificate. Likewise, he has also received other awards like ANERT, then AFST award from the Low Cost Technology Award from AFST. So now I request Dr. S. Murali for his lecture. Yes, sir.
Good morning, Anandal. Hope I am audible. Am I audible, sir?
Yeah, you are audible. You can make a slideshow, PowerPoint, full screen as slideshow.
Yeah.
Okay. Yeah, fine.
So first of all, thank you for giving this opportunity to deliver the invited talk on renewable energy, especially for drying of food products. So for next 25 to 30 minutes, I'll be talking about the solar energy for drying of agricultural produce. So the outline of the presentation is like that. You will have some fundamentals of drying. Thereafter, what is solar drying? Solar drying of some food products. Then what we are basically working on the fish drying. So fish drying, then different type of dryers developed by CIPHET. Then finally, how the dryers reaching the end people, the clients, through some entrepreneurship development. So that that thing will come in the end. So to start with, first of all, what is drying? These things I am not going into deep. So everybody is knowing this. It's not a new technique. So just to start with, I'm just giving some introduction. So it is basically a removal of moisture by means of evaporation. So there it is simultaneous heat and mass transfer occurs. So we are trying to reduce the moisture content. Thus, you are trying to reduce the growth of microbes, enzymatic actions, and other chemical reactions. So what we will do when we do the drying, we will get to know the moisture content. End moisture content will be low moisture. In turn, that will help us in storing the product for longer time. There is extended shelf life. You may be end up in lower storage space, reduced packaging requirements, handling requirements. Then mainly we will be able to give the product during off season. In addition, we will get a value added diversified product that is meeting the some of the consumers' demand. For example, if you say in the fish, some people like to have the dried fish, not the fresh one. So it is like a consumer's demand. One diversified product we can give through drying process. So what are the factors are affecting? You have the product parameters, you have the dryer properties, shape, size, thickness, composition, moisture content, surface area. When it says dryers, you see the type of dryer, design features, temperature, relative humidity, velocity, what is the drying time, what is the flow rate, what is the weather conditions when we say solar dryer. So these are all the factors are affecting. Then we have the relationship between moisture and the RH. You have the food product. There is an unbound moisture and bound moisture. Bound moisture is just like a free water, whereas bound moisture it is attached with the food particles, whereas unbound moisture is a free moisture. So when we remove the unbound moisture and part of the bound moisture, we will end up in the equilibrium moisture that is based on the given drying conditions. What is the temperature, RH, we are giving accordingly, we will end up in the one particular EMC. So then there is a relationship between drying rate and the moisture content. You will see that there is a concentrated drying, falling rate drying. There are two types of falling rate drying period. In concentrated drying, it is not dependent upon the product, whereas falling rate drying period, it is dependent upon the product. In concentrated drying, the temperature of drying occurs at the wet bulb temperature. It's not basically the dry bulb temperature what we see, it is occurring at the well bulb temperature. The water carrying capacity of the air will be met by the product. Whereas in the falling rate drying period, there are two ways. One is first falling rate, you have the unsaturated surface drying. It does not have sufficient moisture to give up. The second process is a diffusion process. The moisture has to come out from in to out. So that's how these two drying rate periods are there. Then we will come to solar drying. See, basically another 20 minutes I will be talking about solar dryer and the solar drying process. This is basically has some advantages over the other drying methods. First of all, it is environment friendly and economically viable. But in solar drying, basically what we will do, there will be a simple structure. Okay, we will make a structure in which we try to enhance the effect of solar radiation as well as natural flow of the wind. By doing so, we will be able to get higher temperature, lower RH, and improved drying rate and lower final moisture content. And also, finally, we will be getting the lesser time for drying, complete drying of the product. So what are the essential parts of the dryer? You can see it in the figure also. There will be a drying chamber. There will be a thermal collector, solar thermal collector, maybe an air collector or a water collector. There will be an air flow system. You should have an inlet and outlet. Then there are different types of solar dryers. One is direct method, indirect method, mixed, hybrid, and the different researchers have classified in a different way. So in the direct method, you will see that the product is kept just below your glass cover. When we say indirect, you can see the figure on the right side. When we say indirect, there will be a glass cover down. The product won't be kept. Product will be kept separately in the drying chamber. When we say mixed, you have the both. You will be keeping the material under the glass cover as well as in the chamber. When we say hybrid, you will be including a backup system. Any auxiliary heating source will be included. So one of the classification from Lingayat et al. 2021, they have done the classification based on whether it is a natural convection, forced convection. Then it is based on whether sensible heat or latent heat we are using. Again, whether it is a direct, indirect, or mixed or a hybrid. Again, direct, that means you are directly exposing the product under the glass cover. So whether it is a cabin based or a greenhouse type. Again, if it is a greenhouse based, then what is the type of flooring we are using? Whether it's a concrete floor, or you have black painted, or it's a sheet, or a sand floor. Then it is a type of glazing material. Basically, when we go for low-cost dryers, you will see that polythene sheets are used. UV stabilized polythene sheets are used for low-cost solar greenhouse dryers. Also, polycarbonate sheet is used. Fiberglass is used. So based on that also we can classify. Then there is a structure, whether it is a single roof, double slope roof, it is a parabolic shape or tunnel shape, accordingly also it can be classified. Then whether you have a north wall reflectors, so that to enhance the solar radiation inside so that we can get maximum heat, or you are not using the north wall reflectors. Based on that also we can classify. When we say in the indirect dryers, you have a solar collector based dryers that I will be discussing in detail in subsequent slides. Then there are thermal storage systems. Some of the materials will be kept inside the glass cover so that that particular material will gain the heat during the sunshine hours and it will release during the off sunshine hours. Say you wanted to dry the material in the night time, or you wanted to do it in the rainy season or cloudy day, these things can be taken up. Also, there is a solar water heater based air water heat exchanger that also I will be discussing in subsequent slides. Again, whether it is based on water or air, that can be again classified into two things. Whether you are using a non-concentrating collectors or you are using a concentrating collectors. If you are using a non-concentrating collectors, there are flat plate collectors, vacuum tube collectors, CPC, compound parabolic collectors. When we say concentrating type, you can see parabolic trough collectors, parabolic disk reflectors, linear Fresnel reflectors. So that way also it can be classified. When it comes to mixed mode, you will see that there will be a cabinet and solar air collector as well. Or you will see that there will be a greenhouse dryer in front of that to improve the preheating. Before letting the air go inside the dryer, you will have a solar air collectors. So the air will be heated up to say 40 to 45 degrees Celsius. Then it will be going inside the drying chamber. Then it will get further heated up to the required temperature. So that way also we can classify. When we say hybrid, there are photovoltaic thermal systems. This is a cogeneration system. It is a mix-up of photovoltaic panel and the solar thermal technology. As Madam was telling in the previous lecture, that when the temperature is more, the efficiency is coming down. You see the panel temperature goes 60 degrees Celsius, 65 degrees Celsius. The literature suggests that when the temperature is increasing every 1 degree, your efficiency, that is electrical efficiency, is down by 0.45%. 0.45%. That means when the temperature is more, your efficiency is down. On an average, we used to get about 12 to 14% PV efficiency normally. But in the hybrid system, what we will do, we will attach a solar collector in the bottom, just below the PVT collector. So it can be cooled through air cooling or water cooling, or we can also use nanofluid cooling. This also we are working at CIPHET. We have developed a hybrid photovoltaic system. Then we wanted to use this system for drying process. Say for any classified dryers, in the left-hand side, for any type of dryer, this system can be used. So the small energy requirements for like running a fan, blower, or small lighting can be done through this system. Similarly, the energy, the water or the nanofluid, what we are using, it will act as a sensible heat storage medium. So when the temperature is more, that during peak sunshine hours, the temperature of the material will rise to a particular degree Celsius. Then during the off season or off sunshine hours, it will start releasing it. So like that we can use it. Then second one is thermal storage, as I already discussed. Then you can have a biomass assisted system, or you can have a LPG assisted system, or it can be an electrical assisted system. One by one I will be discussing in subsequent slides. Then you see Fadoli et al. 2010, they have given the common agricultural products and what would be the initial and final moisture content. What is the maximum allowable temperature? And also how long drying takes place. This is based on solar drying. The maximum allowable temperature is given, initial final is given, how long it takes also they have given. You can see the figure in the right side. there are different types of products. All the agricultural materials can be dried in the agricultural products. Then I am going to the main topic of this presentation, that is dried fish. So say about 17 to 20% of the total catch of the fish in India is dried for export and local consumption. Then whenever there is a excess catch or there is a low value fish, when we freshly sell it, you won't get the that much price, or you see that the product will spoil very early. So during these type of products can be dried. So that is basically dried. Then there was a study in the Southeast Coast Harbor. They have found around 25 species is dried for the dry fish production. And you can see about 2,000 to 4,800 tons dry fish production is happening in the Southeast Coast. See, these dried marine fishes are transported to the inland areas for domestic consumption. And there is a report, this dry fish contributes about 7% of the total fish export. And also, APIDA in 2016 in its reports has given that this dried fish with MAP, modified atmospheric packaging, properly packed and given, this dry fish contribution to the total fish export can be increased to 25%. And I see that there is a figure in the right side that this is the Jagi Road dry fish market in Assam. That is the largest dry fish market in the Asia. You see how the fishes are dried and kept and how it is sold. So from India, Bangladesh is a net importing country. If we say in the wet weight basis, they are importing about 2 lakh tons per annum. So what is the importance of dried fish? It is a cheap source of nutrition. When we dried it, it can be available all over the year. Then it is resilience against the perishability concerns because you are preserving it. Then price fluctuations also can be reduced. Then it is a source of rural livelihood and income. Then during the pandemic and lockdown also, this dried fish has supported the fish consumers. When the lockdowns and pandemic, the present situation, the fisher folks are not going into the sea. So the dried fish can support during these times. Then how traditionally the fishes are dried in India. For that matter, in underdeveloped countries and the developing countries, the traditional method is open air sun drying. You can see the right side figure that is in the Goa coast, and the second one is in the Bombay coast. The first one is spread in the just beach. The second one is hanged in the wooden frames. The bottom one, what you are seeing is called a Bombay duck. There is a fish dried and sold in the name of sticks. So you see the when we do traditionally how they are doing, it is directly exposed to the incident solar radiation and the natural wind, because the energy is free, renewable, abundant, and this type of method is cheap. You are not incurring any cost. Then you see the product is not good. It is inferior quality because it is dependent upon the weather conditions. Also, it is vulnerable to the dust, insects, pest, infestations of microbes. Then there is a study says that at least 30 to 40% of total dry fish production is lost during the open sun drying. When we are doing this type of drying, 30 to 40% of fishes are lost. So keeping these things in mind, different researchers has developed different dryers for especially drying marine products, and they have got the good results. So now I am going to talk about what is our CIPHET initiative, what type of dryers we have developed. Then I will be subsequently giving the results out of that. What is the results we are getting? I will also go into details of how the dryer works. Then what is the energy efficiency we are getting through that? So first you are seeing the solar dryer with electrical backup. There is a 20 kg dryer. This is a flat plate air collector. You can see it from the top. This region, this is the solar flat plate air collector. This is the drying chamber. Then there is a blower here. So during the sunshine hours, the air will go inside, get heated up. Then through the blower, it will be circulated inside the drying chamber. We have also given up with a backup heat source to run during off sunshine hours. You have a control panel. So you can set all the temperature, whatever required temperature can be set. Similarly, we have a 40 kg dryer working on the same principle. There is a flat plate air collector, blower, drying chamber, then heating coil. Next is solar LPG hybrid dryer. In this, we are not using the air collectors, rather we are using the water collector. This is flat plate water collector, what you are seeing in the top. Here, we are using the sensible heat storage system. Thermal energy storage system also we can say it. Here you see there is a tank, insulated tank, in which the water will be stored during the starting of the dryer. That always, once we filled it, we no need to refill it. We can also have a sub tank in the top, so that whenever any leakage is there, it can come and close it. So what happens once we start the dryer, this water from the tank, that is cold water, about 25 degrees Celsius, will be circulated through a pump to the collector. Once it is circulated, it will get heated up. Then the heated water will come and store in the same insulated tank. So this tank will act as a thermocline system. You will see that the top is hot water, bottom will be a cold water, because due to density difference, the hot water will store in the top, cold water will be in the bottom. So again, this heated water will come from the top. That will be sent to a heat exchanger that is placed inside the drying chamber. You can see this is a heat exchanger placed inside the dryer. So the hot water will go to the heat exchanger 1, then it will go to the heat exchanger 2, and then it will come back to the same tank that is in the bottom side. Why? Because when it is going inside the heat exchanger, it is releasing its heat. Upon releasing its heat, it will be cold. So obviously it will come and connect in the bottom side. Again, see, if it is a rainy season or a cloudy season, or you are trying to do it in the night time, so you may not have any control over the solar system. You will not get heated up. So what we have done it, we have kept a LPG backup system. You can see the figure here. Also, you see this tank. So through the LPG system, we have a burner here. When it is connected, and one more thing, this total system is automated. When we switch it on, all the things are automated. We no need to switch on the LPG. Based on the temperature, it will automatically on off. That also I will tell you. See now, suppose it is a rainy season or off sunshine hour. This cold water will be taken up by this pump and it will be heated up by the LPG system. Then this heated water will come and store in the top. So again, this top, from top only this water is taken to the heat exchanger. So here we are trying to maintain to about 80 to 90 degrees Celsius in the top temperature. Water temperature will be maintained about 80 to 90 degrees Celsius. Then when it is going inside, it can give about 20 to 30 degrees Celsius difference. It will go away. So that means in the drying chamber, we will get it about 60 degrees Celsius. So 55 to 60, that range we will get it. Then this water will come as about 30, 35 to 40 degrees Celsius. Again, store it in the bottom. Now, there is a case, if the cloudy cover comes in between, this water will not get heated up. So we have a differential system, solar thermal differential controller. So what happens? There is a temperature sensor in the top and there is a sensor in the bottom. It will check always the temperature difference between the tank bottom and the collector outlet. If you say, we can set it, all those temperature requirements we can set. Suppose I am fitting about 10 degrees Celsius. So the temperature will be checked. If there is a difference of 10 degrees Celsius only, this pump will run and the water will come. Otherwise, what happens? It will continuously run. Then all the water will get mixed up. We may not have the thermocline system. Then here cold water will go inside and drying will not occur. So for that reason only, we have kept two sensors to regulate the pump. This is called a solar pump connecting between bottom tank and the collector outlet. Then we also kept one more sensor to maintain the top temperature. See, this LPG system will see what is the top temperature. If suppose it is only 70 and I have set it to 90, this LPG also will work simultaneously. Take the cold water, heat it and put it in the top. Similarly, if the temperature of the drying chamber is going more than 60 or 55, whatever we are setting, there is a temperature sensor here. It will sense what is the temperature inside the drying chamber. Accordingly, if the temperature is attained, this sensor will give a signal so that this pump will be cut off. So with the sensors, we are trying to control all the pumping system. So it is totally automated. We have about 36 trays inside. So each tray we will be putting the fishes in a thin layer. Then we are getting dried. And you see that the operating cost of this dryer is coming about 2 rupees only. 2 rupees 20 paise it is coming. It is a less costing compared to other CIPHET dryers. And one more thing, this blower also will automatically run. This blower will take the cold air from outside. It will go to the heat exchanger. When it is moving across the heat exchanger, the temperature of the air will rise. Then it will go up. Then there is a fan here. So it will circulate towards this direction to this heat exchanger. Again, because this fan is kept inside, it is creating slight vacuum. So this hot air will come here, it will mix with the cold air. So it will form a anti-clockwise circulation inside the drying chamber. We have an exhaust in the back. So this also we have automated with the RH sensor. Whenever the RH is more than 60, 65, we have said that this exhaust will open and the moisture air will be thrown out. So this is how this drying system works. The results I will be showing in the subsequent slides. We also developed a solar tunnel dryer. This is basically a polythene sheet. This is not a very new technology. However, we are trying to customize for the benefit of the fisher folks. The ultimate users, they always come here and ask for low-cost technology. They don't want a hi-fi technology, so they can afford it. This dryer will cost about 70,000 rupees. So you see the UV stabilized transparent polythene sheet is used for roof, and you see the black observer sheet for the floor. Then we have got the CPVC pipes only. If there is a permanent structure is required, that also we are capable of doing that. We are doing it already. There are 3 fans kept for inlet and outlet. You have the trays inside, you can see the figure. You can place the material and we can get it dried. And also we have connected this with PV panels. So we does not require separate energy. There will be a panel nearby. Through that the fans will be running, and we have not given backup, heat backup not given. So slightly the drying time will be more, and it is for affordable bulk dryer. Say it is 1.5 lakhs, we can dry about 50 kg of fish. Whereas when we go for camera type of dryers, same 1.5 lakhs, we cannot dry more than 20 kg. Then these are all the experimental results. We have conducted a study with Indian mackerel, that is salted one. You see at 55 degrees Celsius temperature with the RH of 47 to 62%, with the air velocity of 0.8. We end up drying the material to 31% and 30%. You may be asking this question, why the moisture content is more? It is 30. See, it is salted one. So when the salted one, as per our standards, BAS standards as well as international standards, if it is salted, even the moisture content on the material can be as high as 40% on wet basis. 40, even 45% it can be based on the requirement. So when we dried it with solar hybrid dryer and the open sun drying, we found that within 8 hours, we can dry it in our hybrid dryers, whereas in the open sun drying, it is taking about 32 hours. Why? This is because you are trying to maintain the optimum temperature, that is drying conditions, with the help of backup heating systems. We are achieving that. The drying rate also higher. Then you see here, about 78% of the drying energy requirement has been supplied by the solar air collector. This is a 20 kg dryer, solar air based collector. You see about 78% of energy has been supplied through solar system. And you can see that this drying efficiency of 23.81% was observed for the salted Indian mackerel drying under the solar electrical hybrid dryer. Then we have also conducted another study in the LPG dryer. So the system has a flat plate water collector, thermal energy storage system, then LPG backup. You see the temperature was attained in the maximum of 73 degrees Celsius with the help of collector alone, the flat plate water collector alone. Then if required, we can go for LPG backup. Then we have dried this material to 15% with the wet basis, and within 6 hours we can do this. Then similarly, you can see here the collector efficiency is about 42%, 37% is the drying efficiency. You can also see here about 73%, 74% of energy was applied through solar system, and the LPG supplied the remaining 26%. I also have a comparison chart I will show you. Then we also done a quality analysis. You can see the proximate and biochemical analysis of the dried shrimps were carried out. Then we have found that it's not significantly affected by the drying process. It is microbiologically also safe. Also, we have done this shrinkage rate, rehydration ratio, color attribute, everything is within the limit, and the product is good quality, hygienic, uniformly dried. Then we have also done a energy analysis. You can see it here. See solar electrical dryer 20 kg, 40 kg, 60 kg, 250 kg, 50 kg tunnel dryer. The dryer costing we have given. Operational cost is about 3 rupees, and your drying time is 6 to 10 hours. Manpower required is only 1. You see, if it is operated in a hybrid mode with solar and electrical, you end up in 1795 units per annum, 1 year, about 240 days of operational days. Whereas if you are only doing with electrical, you will end up in about 4,500 units of electricity. You see for same 40 kg dryer, you see for LPG 60 kg dryer, how much difference is there in terms of energy? About 40 to 50% difference is there in the energy consumption. And then when it comes to tunnel dryer, we have not given backup system. This actually only maintenance charges are there, no operational charges. Drying time is, it will take about 1.5 to 2 days. And the labor also 2 people are required. Then see, we also have done a system to get the details of drying. See, most of the time when we do the experiment, we don't know what is the temperature of drying, what is the temperature in different zones. We don't know the temperature profiling inside the drying chamber. We don't know what is the RH. So if you wanted to know, we have to open it and check it, or we can have a data logger from outside, we can give it. However, when we are giving to the ultimate user, the client, he may not be expert. So he wanted to know what is happening inside the dryer. So what is, how much drying happened, how much moisture has been removed, when drying will complete, all those details. So we have developed a system with the sensors, temperature, RH. Then there will be a load sensor, and we have assumed some assumptions. Based on that, there is a Arduino board, there is a load sensor, and you have a GSM module. With this, we will be able to get the SMS. We have to feed your mobile number. Upon feeding, you will get the item is kept for drying initially when we are keeping it. Then we can set the time interval, at what time you have to get the message. Maybe after 15 minutes, 30 minutes, 45 minutes, or after half of the drying is over, or if it is completely dried. So all the details, we can get it through mobile. This we have actually got the copyright for the algorithm what we written in this. So this system we have not yet commercialized, but we have already experimented. And we also wanted to control the switch of the dryer itself when the drying is over, that we are presently working on it. So this is about the automatic information system for the dryer users. Then overall, what are the advantages? We have different dryers suiting different requirements. Energy efficiency, you can see about 42 to 59% less energy required for the solar system. It is renewable, no emission, no fossil fuels are used because we are using renewable energy. It can be easily installed and can be operated. You see that operational cost is very less. Construction also. If you take 250 kg dryer, it is coming less than 14 lakhs. The drying time per batch also 6 to 8 hours. If it is tunnel, it will be a little bit higher. Labor requirement also considerably reduced because you are not going to turn it. Once you put it inside in a single layer, thin layer, then we are not going inside and then we are shuffling it, all those things. So the labor requirement is very less. Then improved self-life, value addition, and it can be finally used by any individual small-scale industries, fishermen or aquaculture farm. Then which are the places we have installed this dryer? You can see this is a solar LPG dryer, 250 kg capacity. We have installed this at ICAR Research Complex for Northeastern region at Impal. This is a professional commercial model. All parts you can see, these are the trays, SS trays, 304 trays. So then we also installed one more dryer of same capacity, 250 kg, Alapla, Kerala. See, this is also same principle, LPG system. But instead of one LPG, here we will be having 3 numbers. Then burner also will be 4 or 5. According to the requirement, it can run. Based on the temperature sensor, it will run required numbers. Then we also installed a solar electrical dryer at Directorate of Fisheries, Manipur, 100 kg solar electrical dryer, working based on flat plate air collector. Then we also installed one commercial model hybrid solar fish dryer with LPG backup at ICAR Siva, Bhubaneswar. This is also working good there. Then now recently there is a walk-in type solar tunnel dryer. I already shown you the temporary model. This is a permanent structure what we are doing with polycarbonate sheet of thickness 6 mm with a GI purlin. It will be a permanent structure. Then Kadapa tiles for the bottom. So this with the World Fish project, we are giving 10 number of these dryers to Odisha coast. This has been already installed. due to cyclone, we have also removed it now. So it can be installed, and if you want also during any exigencies, it can be taken out. So the bottom structure, this plain concrete and the Karapa tiles will be there. This top portion can be taken out if required. Then through our ITME ABA section, we have empaneled manufacturing agencies for fabricating our dryer, supplying to anywhere in the world, including India, anywhere they can supply. You see that for last few years, we have supplied more than 30 dryers. We have supplied to Andhra, Karnataka, we have supplied to Northeast, Odisha also we are doing. We have different capacities. And as of now, for last few years, our installed capacity is about 1,400 kg dryer has been installed. Then I was talking about the entrepreneurship development. So what we used to do is that we basically conduct the drying trainees. About 2 to 3 days, solar drying trainings will be conducted at CIPHET. The interested people will come there and get trained. Upon getting trained, they will register with our ABA, ITME section, and they will be called incubating. We will enroll them for 6 months. So during these 6 months, they will bring their produce. It can be replicated for any products. For fish, they used to bring it and dry it in our campus. So this facility is given for 6 months. Upon drying, they get to know the technology. They will do the test marketing. They see that if this technology is working well and good, then they will finally come to us and take the dryer with the help of the empaneled agencies. What you are seeing in this slide is, you see some of the installations at Kerala. It is installed in the rooftop, about 20 kg solar electrical dryer. There is a 40 kg installation here. This is also in Kerala. Then you see one dry fish shop also with the help of CIPHET guidance, one of the young entrepreneur developed. You see all the fishes are dried and kept in just like a bakery. It's like a nuts, they have been kept. Anybody goes there, they will get tempted to purchase different items. So it was one interesting initiative by one of our incubating. Then you see, these are all the products that are available in the market now. With the help of CIPHET, with using our CIPHET technologies, especially solar dryers, they have brought out these many numbers of brands for dry fish, and they are in the local, in the Kerala level, and some of the people are working throughout India also. Some are trying to export also. So you see the different brands. These are our incubators. You can see this. Thank you.
Thank you very much, sir, for your nice presentation, briefing about the different dryers and technology which you have developed, including the fish dryer. Thank you very much, sir. For next presentation, it's my presentation, and I'll be sharing my screen. Is it visible to all?
Yes, visible.
Okay.
Full screen slideshow.
A very good afternoon to all. I'll be presenting on the topic application of solar energy in plant utilities of food processing. So, other than Ma'am Sangeeta Ma'am has explained about the cold store, cold chain, and Murali sir also present about the dryers. So I'll be covering other applications which we can use domestic level as well as in the other plant processing plant. I'll be discuss about the renewable energy in post-harvest sector, solar energy and its advantages, application of solar energy in food processing. So why solar energy? Why what it is, and what is it? Why it is very much important and need. We know that population is increasing. Due to the increase in population, the demand of the energy is also increasing. Cost of the fuel is increasing, and due to the reduction in the conventional energy source, nowadays are searching and focusing on the alternate source. What would be the options if it is since it is limited conventional source? What would be the alternate source for the energy? So focus is made in the renewable energy. Moreover, it is freely available. It is a green source, and also solar energy becomes the ultimate energy source because directly or indirectly, whatever energy comes, either biomass or either petrol or fossil fuel, everything it has come through the solar energy, directly or indirectly. Moreover, the government has also provided different schemes and missions related to the solar energy to improve and to popularize the use of the solar energy. So, if we see this India map, it is shown that the solar energy potential of the solar energy that our country has. So western and the northern part it has a maximum, but overall distribution to the minimum we are getting 4.6 to 4.4 kilowatt hour per square meter. So that means we are having a good potential of the solar energy by location, by geographical location. So application of the solar energy in post-harvest sectors. So renewable energy, when we say renewable energy, we can use wind energy, we can extract hydrothermal energy, either geothermal, biomass, biogas, and solar energy. But as I had also mentioned, like wind, hydrothermal, either some way or the other, it is influenced by the solar energy. But solar energy is the only one which we can obtain directly through the medium, through some collector. So why solar energy and what are its advantages? So first of all, the solar energy from solar energy we can get both thermal and electrical power simultaneously. Like thermal collector, by using thermal collector we can get the heat generation or the thermal power we can get, and electrical power we can accept through the solar photovoltaic panels. And on the other hand, it is also freely available, inexhaustible, abundant, environmentally clean, and now it becomes a promising alternative energy source. And so hence using solar energy in post-harvest sectors, it is a sustainable way. It becomes a sustainable way. And as I had also mentioned, shown in the graph, shown in the map, it is reported that India has 5,000 trillion kilowatt hour per year with 3.5 to 6 kilowatt hour per square meter of solar radiation per day, with an average clear sunny days of 250 to 300 days. That means we had a very good potential of solar energy. So we should harness and we should use it as an alternate source of the conventional energy. So application of solar energy in food processing in post-harvest sector, there are a lot of application wherever energy is required, like either in the electrical or either in the thermal source. As I had also mentioned, solar energy we can use. And post-harvest sector, it is a very energy-intensive zone, sector. So it also requires energy, very high amount of energy, and hence major part of it can be made by the solar-based system to achieve sustainable growth. Thermal energy can be harnessed for utilization in drying, cooling, steam generation, whereas electrical energy we can use for the water heating, for boiling purpose, for the electrification, for the operation of the solar appliances of the equipments or the machineries of the post-harvest processing. So solar water heating, it is a simple natural process, thermosiphon system, and in this, due to the convection process, hot water will turn into the top part of the water tank after once it receives the energy from the sun, and hot water will get collected and cold water will supply as shown in the figure. This can be installed either in the laboratory, household purposes, or plant in processing plant, wherever the hot water is required. So again, this is for circulation. In this one, the water storage tank can be installed at any place since we are using pump, and it required electricity to operate the pump. And this electricity, once again, we can provide to the solar photovoltaic panel, and hence totally heating process of this water can be done through the solar energy. Next is solar cooker. So a solar cooker, mainly there are two types. One is the box type solar cooker, another is the concentrating type community solar cooker. In box type, what happens, like the rays and rays will reflect into the mirror through a mirror, and then the product or the box or the bended will bended in the plate, and the material to be cooked will place inside the box, and due to the heat, reflected heat from the mirror as well as the heat absorbed through that cover, it will get cooked. And on the other hand, concentrating type community solar cooker, in this one, there will be a focus point, and in that point, cooking pot will be kept, and all the rays will be concentrated and focused in that particular point where the product is being kept. Solar refrigeration, three types mostly, and it is solar PV cell-based refrigeration system, solar mechanical refrigeration system, and another is solar vapor absorption refrigeration system. So all this we can operate through the solar energy. So it's like as usual, like we need power to operate the refrigeration system. That power we can get it from the solar panel, and for this, since we get DC power from the solar energy or the solar PV panel, we need an inverter, and then we can supply whatever required it is there. Other than this is not only for the refrigeration, for other appliances also. Similarly, for the solar vapor absorption system, in solar vapor absorption system, we need the heating of the refrigerant. So both the heating as well as the for operation of the pump and the other things, we can use both the thermal as well as the electrical source of the solar energy. Next is the solar desalination unit. In this one, this is usually done for making the drinking water. From the saline water, when we evaporate the water, then the water will get condensed and collected from the other side. But the salt that is present inside the water, it will get collected at the bottom, since it will not evaporate. So this is the fundamental of the solar desalination. It will depend on the area of the solar surface, means exposure area, and the incident angle also. Indirect desalination. When we say indirect desalination, it will cover like other from the solar photovoltaic panel. Like solar photovoltaic panel will use as an energy source to operate the unit system of the desalination. Like it consists of the thermal collector, it may consist and photovoltaic also. So these are some of the solar photovoltaic operated milling and winnowing machines. And as I had also mentioned, other post-harvest equipment or the machinery which require power, it can be supplied from the solar energy through solar photovoltaic panel if electricity is required. Other than that, in the food processing, if heating is requirement, like boiling, then blanching, then heating, drying. In such cases, we can extract the thermal energy of the solar from the solar. So Dr. Murali has also explained about the solar dryer, and I would also like to brief little bit about this one as a part of this. So why we go for the solar dryer? From time immemorial, since ancient times, sun drying has been practicing, and for the preservation of the crops. And sun drying, there are certain limitations of sun drying that includes the damage to the crop by animal, bird, rodents, degradation in quality. Hence, solar dryer is important. And on the other side, the other drying method, why solar dryer is very common and is widely practiced and widely research has been made on this one, because other drying, commercial dryer like the tray dryer, vacuum, freeze dryer, they are very energy intensive and it is not easily affordable to the farmers. So classification of solar dryer, we have also seen in the previous lecture. One example of the greenhouse dryer, we have also seen in last one, and this is one of the solar tunnel dryer which is developed in the ICAR Northeast region, Research Complex Northeast region, for the turmeric drying. Again, here comes the solar bubble dryer. We have many dryers for the fruits and vegetables, and when we come to solar bubble dryer, it is for the food grains and pulses that include that may be paddy or wheat, and other pulses also. It is made of the transparent polyethylene, which is covered with the UV and water resistant, and it acts like a bubble. As I'm as I'm showing in this figure, using the photovoltaic panel, the exhaust fan will be operated, and then it will be a bubble kind of air will be inflated in this structure, and ventilation will be provided. And on the other hand, thermal energy is exit from the top of the transparent polyethylene sheet, and it is the top cover and the drying floor. It is joined together by a heavy duty zipper. So likewise, this is meant for the paddy dryer and the paddy wheat, etc. And for mixing purpose, suppose like for uniformity drying, one rod or this one through mechanically or through manually, it will be rolled, and the mixing can be done during the drying process. So that's all from my side. Thank you very much. A brief about the application of the different application of the solar energy in the post-harvest sector. So it's open for discussion, and from all the last three lecture, we can discuss on that.
If anybody is having any clarification or to supplement or complement, kindly raise your hand so that or I will allow you to unmute yourself.
Or in the chat box also, one can write for the.
In chat box, they were there, but many of them have already been answered by the speakers. If anybody has anything to say.
And I request all the participants to provide feedback, which is shared in the chat box.
So before I see a lot of senior person like Professor Vishwanathan is there. Our PC is Dr. R.K. Singh, Dr. Tyagi, and Dr. Dilip Jain, who have seen and worked a lot in the solar energy. Dr. Ravindra Nayak is there. Many others are there. Dr. P. Srinivas Rao from IIT Kharagpur is there. So if they have anything to supplement or complement, because we have chosen many speakers who are in the initial phase of their career to encourage them, so give their feedback or from their experience to bless them or give feedback on their things or to supplement to their presentations. I invite them to give brief. Any of them have anything to add?
Good afternoon, Dr. Marseya. Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Good afternoon, sir. Nice to see you, sir.
Yeah. Thank you.
Just adjust a little bit camera. Your face is half visible. Yeah, it's fine.
Okay. So it was a good session. There are good speakers, 3 speakers. In fact, I have visited at one of the sites where Dr. Sangeeta has installed the solar assisted refrigeration system or solar operated refrigeration system. It was good work. So we should look for some agency who can take this technology to the rural area.
Yes.
To say safeguard the perishables till they are taken to the market. Something like we should approach like the milk chilling plants in the rural area before they are taken to the milk processing units. Then regarding the fish, lot of work has been done in preservation, drying and all, but I see the work in packaging of dry fish is less. I have also mentioned in the chat box, because they simply take it in the gunny bags and throw it during handling, transportation, they overload it. And ultimately, such a long fish taken care by the fishermen and the processors to dry it and maintain the shape, length, everything, it when reaches the ultimate consumer, it is completely lost. So that should be taken care so that they are well packaged and the shape, size, everything is retained till reach the consumers.
Yes, sir. That's what we are doing, sir. You might have seen in our last presentation slides. There are properly packed fish packets, whatever I have shown in the last slide.
Okay.
So we are doing in nylon, polythene, polyester packaging material. We also have a separate packaging section at CIPHET who are working on it, sir. Different types of packaging they are working.
So you can also consider to release some gas inside the package so that when it is opened, it will not give any, say in some fishes you will not, you will get some say unpleasant smell and all. So that will, so though after cooking it gives a good taste and all those things, but some people will not like to smell the dry fish. So that approach can also be incorporated in the packaging.
Yes, sir.
Okay,
Thank you,
good. So my appreciations for the work going on.
Thank you.
Thank you, Dr. Narsaya.
Thank you, sir. Thank you for your valuable inputs and encouraging words.
Well, thank you, Dr. Vishwanathan. Dr. Vishwanathan is also member of our research advisory committee. So his comments are definitely very valuable to us as a CIPHET and as well as for the profession. Thank you very much.
Thank you.
Yeah, Dr. Narsaya, you can go
Yes,
ahead
sir.
for other comments.
Yeah, I request if Dr. Dilip Jain also is worked a lot in solar energy. I think in Kajri they have established for powering whole campus or major part of the campus, as well as in processing also he has done for like solar drying with phase change materials. He initiated
Oh,
here.
Dr. Narsaya, he has worked in fish drying also.
Yes, sir. Yes. So he has, without touching fish, he has handled the fish very efficiently. So if he has anything to add, I request Dr.
I was about to mention that. I was about to mention that.
Thank you very much, sir. I think the way the seminar was organized by Dr. Narsaya was really fetching the interest to me, because by heart I am a post-harvest technology man, and from the work where I am presently placed is the solar energy. So we have been looking since long that how the best solar energy can be utilized in a post-harvest, and I think that the conference or the way the presentations have come is in a very right approach, because after all we have to think that how to save the energy, because processing normally consumes a lot of energy for all the operations. The drying has been done since long, but the work of Dr. Sita Chopra was absolutely the innovative idea for storage. And even the fish, the way Dr. Murali has presented was a wonderful. He has not done a work at a one place, at many locations, and the many locations results are really wonderful. I think it will be a good beginning, and I feel that in each and every corner of the country, the solar energy is being utilized for the processing applications. Will be a wonderful approach. And for other domestic things, we have been already doing, like developing the energy for the domestic use, a 5 to 10 kilowatt system for the rooftop. So why not the processing part? Why not the processing of a small machinery? Those are attached to the solar system, maybe a thermal or maybe a solar powered, solar power generated system, PV system will be a good approach. Once again, my compliments. And CIPHET has started. When I was there, we were not touching the solar energy at all. I took the first project from DST. Unfortunately, I was transferred from there. So that project has come to the Kajiri, but I still give the compliment to CIPHET. My still heart is there. and I wish all the best to all the team.
Yeah. Sir, kindly say about the whole campus. You are having a solar farm or something in Khajri. Few words to others, enlighten others about that also.
Okay. Thank you, Dr. Narsingh.
We got some questions in the chat box. So the question is, what is the payback period if you are storing different perishables in cold room? This could be answered by Dr. Sangeeta. Yes, ma'am.
I saw the question. So there were other questions which I've answered over there in the chat box. So this question I was yet to answer. So I still haven't calculated, so I wouldn't know actually. That's why I was thinking. And the cost is around 5 lakhs. So what kind of business the person can do depends a lot on the farmer himself, the location of the cold fridge, wherever it is. Uses no electricity, so there are no running expenditure, no operating cost like that. I would say, so 5 lakhs, I would say 3 years maybe, if he does good business. Like what happened in the coronavirus times is people started storing eggs also. In Ajmer, they were storing eggs for a long time and got profit in the summers. And I wanted to also say to Dr. Vishwanathan that we have ICAR is commercializing the technology. So we've already commercialized to one particular company. And in the past 2 months, since the Farm Sun Fridge has come up on the Mela ground, I've got like around 30 people calling me, some wanting license, some wanting us to build structures there. So a lot of inquiries are there. And we have a website. I've put in the website name here, coolsunproject.com. So I would like people to visit the website and have a look for more details. That's all. Thank you.
Thank you, ma'am. Thank you. Another question is, drying is low and there is possibility of development of microorganism to a level which is not acceptable. How can we control this during solar drying? This could be answered by Dr. Murali.
That has already answered. Actually, when we do drying, we are not saying without backup system. We have given the backup system, either electrical or LPG. When we give the backup system, we can maintain the set temperature. What is the temperature requirement? Can be maintained. Upon maintaining the temperature requirement, within the time frame, we can try it. So when we done the quality evaluation also, we have found that it is microbiologically safe. You see that 10 to the power 4 log CFU per gram less than microbes only. Total plate count we have found. It is microbiologically safe. The temperature can be maintained in the solar dryer with the help of backup systems or with the thermal energy storage systems. It is absolutely fine. There won't be any microbial contamination, microbial growth in the dried product. And the dried product can be stored at least 6 months to 9 months. It can be stored. That too in the room condition. Not separate requirement is not required. If it is properly packed and kept in the room conditions, it can be stored for at least 6 months.
Thank you, sir. Any other queries from the participants, please?
You can see raised hands. I can see.
Yes.
Yeah. Dr. Devendra Dhingra has a raised
Yes,
hand.
yes.
You can see his hand at least.
Hello,
Yes.
everyone.
Yes, sir. Yes, sir, please.
These are very nice presentations. And there is only one question that in the participants, I can see so many engineers. I have been also doing, as engineers, we are focusing more on the equipment, temperature, humidity, and others. But in the meantime, we just forget about the food safety. So as Dr. Murali has already answered to some extent, as far as food safety is concerned, there are two kinds of microorganisms which we have to watch. One are indicating the hygiene conditions, hygiene indicator microorganisms, and the other are food safety organisms. And food safety organisms are mostly the pathogens. So we have to see that during our processing, even if it reaches 10 raised to the power 4 CFU per gram, so there is a lower limit of 10 raised to the power 3 CFU per gram. If you look at the FSSAI standards and international standards, and I think we shall not allow our product to have that much of microorganism load, so that after, when we are going to pack it and when we are going to use it after 3 months, 2 months, the number of microorganisms may grow, which are related to hygiene. It indicates the hygiene practices. Even in our drying system, cold storage systems, we will have to take care of the hygiene. Whenever we are bringing fish, I think it will also come. It can also come with some of the pathogens also. So what kind of pre-treatments or what kind of things we can add so that we can also take care of the food safety, which is of utmost importance. If the food is not safe, our dryer may be the best, but if it is not able to keep the food safe, then we will not be able to use the technology properly. That is only a kind of suggestion that we may also include testing of food safety in our products. Thank you.
Thank you, sir. Kindly share videos, sir. We would like to see you from CIPHET. Warm greetings from CIPHET.
Oh, yes,
and
okay, the
to
camera
hear
is
you
not good.
after a long time. Yeah.
I am 12,000 kilometers away.
Okay,
So
no
you
problem.
will
But
be able to
thank you, sir,
properly.
for joining and sharing your this. Good to see you, sir.
Last 2 months, all the saloons are shut. So we could not go for even haircut. So doing the haircut also at home.
Okay.
Can you see my video? Oh yeah.
Yes, sir.
Yes, we
Good
can
to see
see.
you.
We can,
Good to see
we
you
can
after
see.
long time.
You should show outside the window, Fiji. Yeah. Fiji outside.
It was very interesting. I'm feeling homesick, but it is my native town also. So it's wonderful that you guys have started this program and invited me to attend it. I'm so thankful to all of you, including Dr. Nachiket and all of my friends in CIPHET. Thank you so much.
Thank you, sir. If our project coordinators and heads, if they have anything to add, they are welcome.
Meanwhile, I request all the participants to provide their feedback, which has been sent in the chat box through that link.
That link is not opening, madam.
I'm sending it again.
Otherwise, you send to that mail ID.
Okay, thank you.
If there are no further these things, then I saw Professor Paulur Srinivas Rao from IIT Kharagpur. If he has anything to add, Dr. P. Srinivas Rao from IIT Kharagpur.
Dr. Narsaya, I have nothing to add because I never worked in. I never worked in solar, but it's quite interesting and a lot of information has been shared. And thanks to you and CIPHET as well. My compliments to all the speakers. So they have actually shared wonderful information. Many of them are quite innovative also. So that way, in fact, the profession is fortunate to listen all of them. So thank you so much. Thank you for inviting me.
Thank you. Dr. Ravin Nayak and others, if anybody is having anything to add. Okay.
Dr. Narsaya, I'm Dr. Manikandan.
Dr. Manikandan, how are you? Fine. Good to see you.
I'm fine. I'm fine. I have only one doubt. So it's a basic doubt to Dr. Murali. Can I?
Yeah, tell me, sir.
Dr. Murali, you one of your slide mentioned about that solar dryers with water heating arrangements.
Yes,
any specific advantage of water heating? Instead of that, directly you can send the hot air. No, that is
sir,
very
that is
basic doubt. Kindly enlighten me.
I will tell you, sir. Sir, that specific heat capacity of water is 4 times higher than air. So during the sunshine hours, the water can store the heat. Whereas if you are using a hot air, only during sunshine hours, you will have the heat to supply to drying chamber. After 5 o'clock, you may not have anything. Instead of that, when you store the water, the heat is stored in the water. So it can serve for another 2 to 3 hours without solar radiation. So that's how the energy is stored in the water and that is subsequently used.
But any cost escalation due to that water heating arrangement?
Sir, as such in water, there is nothing, sir. We have provided a LPG backup. That costing is there. However, when we done the calculations, economic evaluation, we have found the operating charge is only 2 rupees for the LPG dryer. Solar dryer assisted with LPG water system, the costing is coming about 2 rupees. Whereas for electrical dryers with the solar backup, solar dryer with electrical backup, it is coming about 2.5 to 3 rupees. Whereas LPG dryer, we are having an operational cost of only 2 rupees.
What is the cost of the system? You said that the whole cost of the system.
50 kg solar LPG dryer will cost 4,20,000, sir.
It's 4 lakhs. Okay.
Yes.
Thank you. Thank you, Director.
Thank you, sir.
Okay, Vidya, okay, can we go for now interaction and feedback? If anybody has anything to offer, they can raise hand or they can give. Otherwise, we can move to closing ceremony. We are well-attended vote of thanks.
So, coming to the end of this program, I request Dr. K. Narsia, Head SNEC Division, ICAR CIPHET, for the vote of thanks.
Thank you, Dr. Vidya Lakshmi. I thank our Honorable Director, Dr. Nachiket Kotwaliwale, for guiding us and in formulating, organizing this symposium. His critical inputs are always there. So we thank him for those things and for enabling us to organize this symposium. We thank the speakers who have Dr. Sita Chopra, Dr. Murali from CIPHET, Dr. Sita Chopra from IRI, and Dr. Vidya Lakshmi from CIPHET. So all of them had good presentations which evoked a lot of interest among participants, and they were crisp and to the point and more useful. We had some entrepreneurs also in the list, but some have participated. Because these systems are directly, they can be taken to market, so entrepreneurs can directly take them to the field and use them. So if any entrepreneurs contact these speakers, they will provide all the help. So we assure on behalf of them also, and we know them, so we assure to the entrepreneurs that if any of you have any interest in these systems, they can help you in taking it to installation or operationalizing the system on the field. So our speakers will help you. And I thank our head project coordinators, Dr. R.K. Singh, Dr. Tyagi, and our heads of divisions, Dr. Mrudula, Dr. D.N. Yadav, and Dr. Ramesh Kumarji from Abohar, as well as other colleagues joined from CIPHET, as well as all the participants who have taken out valuable time and participated in this symposium. And I thank Professor Vishwanath, Dr. P. Srinivas Rao, Dr. Ravindra Nayak, Dr. Manikanthan, Dr. Kalimullah, professor in Angrove. He is also there, I see, and Dr. Vishnuvardhan and others, many others are there in the participants. I thank all the participants for taking out time to attend this seminar and participating in the symposium and enriching our experience for the both speakers and other participants also. I thank you all, and with this we close this symposium. Thank you one and all, and please give the feedback, and if you have anything further questions or further queries, we are eager to help. Thank you very much.
Thank you. Thank you so much, Dr. Sir.
Thank you.
Thank you, sir.
Thank you. Thank you so much. Bye.
Thank you.
Thank you, sir.